It says on 5.2, number 40, to show that these are inverses of each other by plugging one into the other. And figure out what domain the range is, or domain is for this. So we're going to do f of g of x, and f of x on this, on number 40, is x minus 2 quantity squared, and it says x has got to be greater than or equal to 2, so we're only using half the parabola. This is a parabola that's moved left 2, and we're only using the right half of it. And then we've got a square root function here, g of x equals the square root of x plus 2. And we're supposed to put g of x in for the x, so we get parenthesis in place of that x, square root of x plus 2. That's it for the x. And then we got minus 2 squared. The plus 2 and minus 2 cancel, and then we got the square root of x squared, which is just x. Inverses of each other. And we're supposed to do it the other way too. We're supposed to do g of f of x. So we're going to put f of x in place of the x, so we'll have the square root of x minus 2 squared plus 2. Well, the square root of the square cancels, and I got x minus 2 plus 2, which is x. So that shows that they're inverses of each other. And then we're supposed to determine if there's anything that we got to exclude in the domain for this composite. Well, I can put anything into this one, and I'll get numbers from 0 and greater out of this, because it's a square, so it can be as small as 0 and then greater. And I can put 0 or greater into this, so I don't have to exclude anything in this one. So the domain is all reals. Now the other way, what can I put in here? Oh, the domain has to be, already is restricted to x is greater than or equal to 0, so I got to keep that. Now this way, this domain was restricted. Did it have a restriction on this one? I think so. I think we needed to have x is greater than or equal to 0. And if I put any of those numbers in there, I'll get positive number plus 2, which is going to be numbers greater than 2. So the domain this way is going to be all reals, where x, greater than 2 on this other one. And this one is going to be x greater than or equal to 0. Okay? And 43. 43 says do the same thing, so f of x is 2x plus 3 over x plus 4. G of x is 4x minus 3 over 2 minus x. So let's put g into for the x's of f first. So that would be f of g of x. So I'm going to have f, which has 2x, which I'm putting g in for, plus 3 over x plus 4. Now, to clean this up a little bit, I'll multiply the numerator by 2 minus x and the denominator by 2 minus x. This times this quantity, the 2 minus x cancel, and I get 8x minus 6. And then I have 3 times the 2 minus x, which is going to be plus 6 minus 3x over 2 minus x times this quantity would leave the 2 minus x would cancel, and I'd get 4x minus 3. But then I got to take the 4 times this also, which is going to be plus 8 minus 4x. The 4x's and the minus 4x cancel. Negative 3 plus 8 is 5. 8x minus 3x is 5x. And the 6's cancel. So 5x divided by 5 is x. They are truly inverses of each other. So that was the first thing I was supposed to show. And now, how would I have to restrict the domain? Well, I can put everything except negative 4 into, start with here. Everything except 2, because that's what I'm starting with, G. So the domain has to be restricted, so I can't use 2. X cannot equal 2. It's all reals except 2. In this, and everything comes out of this except these have equal degrees, and 4 over minus 1 is minus 4. As the horizontal asymptote equal to degrees, so I use the ratio of the coefficients. 4 over minus 1 is negative 4. I do not get negative 4 out of this. That's a horizontal asymptote. Well, that happens to be what I can't put into here, so this will not produce anything that I can't put into there, and so the domain would be just don't let x be negative 2. So I'd say all reals except 2. Now doing it the other way, which I haven't done yet here, I would have to put f in for the x's here, and then I would do the same simplification, and I would start off with I can't let x be negative 4, and what comes out is, see, this is equal degrees, so 2. I would never get a 2 out, and that's okay because this one can't take a 2, so going the other way, plugging this in for the x's, do similar simplification, and you'll come up with the solution. No, I said that wrong. I got to put f, this one, in for the x's here, and I'll multiply numerator and denominator by x plus 4. I'll leave that one for you to finish up. Now 67. 67 says find the inverse and find the domain and range. So if f of x is 2x over 3x minus 1, then I'm going to change the y to an x and the x's to y's, and so I'm going to get x equals 2y over 3y minus 1. So I swap this y to make it an x and these x's to be y's. Now I got to solve for y. Start off by multiplying both sides by 3y minus 1. Now on this side they cancel and I get 2y. This side I get 3xy minus x. I'm trying to solve for y, so I should get all the y's on the same side. So I'm going to subtract 3xy, subtract 3xy, and I end up with negative x equals 2y minus 3xy. And this is where students get stuck. They don't see that you can factor out a y, and so you get y times 2 minus 3x. So if I divide both sides by 2 minus 3x, I get y, the inverse, this would be by itself now, so f inverse of x, or y, this is y, will equal negative x over 2 minus 3x. The one number I can't use in here is 2/3. If you set that equal to 0, you'll see x will be 2/3. But the one thing I don't get out of here is 2/3, because that's equal degree, and the horizontal asymptote would be 2/3, the ratio of the coefficients. So all I have to be careful about is that I don't put something in. If this, I'm doing this one, I can't put in 1/3, and this one I can't put in 2/3. So they ask for the domain and range of F inverse. So the domain of F inverse is all reals except I can't do 2/3. And the range of F inverse is going to be the domain of F, which the only thing I can't use is 1/3. The only thing I don't get out of here is ratio of the coefficients here, -1 over -3, or 1/3. All right, that's 5-2.